Welcome to our competency-based question series designed chapter-wise to enhance your conceptual learning and understanding. Question 9. Two magnets with magnetic moment M1 as 1 ampere meter square and M2 is equal to 4 ampere meter square are directed along the magnetic meridian as shown in the figure. If P is the point along the magnetic meridian, at a distance d1 is equal to 20 centimeter from the center of magnet 1. So this is the point P. This point P, it is at a distance of 20 centimeter from the center of magnet 1. Now we have to place one another magnet M2 at a distance d2 from P such that the value of magnetic field at P becomes 0. So it will always be 0. Before going into the question, let us study about two important concepts. The magnetic field at the axial point of a magnetic dipole or a bar magnet. So if I take a point P that lies on the axis of this bar magnet, and if this point is at a distance x from the center of the bar magnet, then B axial, it is given by the formula mu naught upon 4 pi multiplied by 2m by x cube, where m is the magnetic moment of this bar magnet and x is the distance of point P from the center of the bar magnet. And the direction for this magnetic field, it will be along the direction of magnetic momentum, that is from S to N. So this will be towards this side, B axial. Now, if we need to find the magnetic field at the equatorial point of the same magnetic dipole, so this may be the equatorial point that lies on its perpendicular bisector, then the value of the magnetic field will be mu naught upon 4 pi multiplied by m upon x cube. And the direction will be along opposite to m. So that will be from N to S. So this is the key concept that is required to solve this problem. Now let's try to solve it out. It has been given that this point P, it is at a distance 20 centimeter from the center of magnet 1. So magnetic field B1 due to first magnet, so it will be B1 is equal to mu naught upon 4 pi 2m1 divided by x cube. Since this point P, it is along the axis of the first magnet, we will be using the formula for the axial magnetic field. And it will be 4 pi multiplied by 10 to the power minus 7, that is the value of mu naught, divided by 4 pi multiplied by 2 into 1. The value of M1, the magnetic moment for this bar magnet 1, it is 1 only, 1 ampere meter square, divided by x cube. And x cube, x is the distance of the point P that is given to us as, x is given to us as 20 centimeter. So we can see x is 20 centimeter. That is equal to 0.2 meter. So we'll be using 0.2 cube. 4 pi gets cancelled out with this 4 pi. And we are left with 10 to the power minus 7 multiplied by 2 divided by 8 into 10 to the power minus 3. 0.2 can be written as 2 into 10 to the power minus 1. When we cube that, it will become 8 into 10 to the power minus 3. So it will be equal to 1 by 4. 1 by 4 is 0.25 multiplied by 10 to the power minus 4 Tesla. So this is the value of B1. Now, this horizontal component of magnetic field is also here. So this horizontal component of magnetic field is also present. And the direction of this horizontal component of magnetic field is along the direction of B1. So net field at B1, it will be B1 plus B horizontal component of magnetic field. Both are in the same direction. So it will be equal to 0.25 multiplied by 10 to the power minus 4 plus the value of BH. And we can see in the question, the value of BH is given to us as 0.3 into 10 to the power minus 4. So we can add this BH to the B1 in order to get the net magnetic field. So that will be equal to B1 plus BH 0.25 multiplied by 10 to the power minus 4 plus 0.3 into 10 to the power minus 4. That will be 0.55 into 10 to the power minus 4 Tesla. Now, we have to place another magnet 2 at a distance d2 such that the net magnetic field at P becomes 0. So, for field to be 0 at P, B2 has to be equal to B net. Just we have learnt that this point P is the equatorial point for this magnet 2 and the direction for the magnetic field, because of at the equatorial point, it will be from north to south. So this B2 will be acting in the downward direction. So this will balance out this B net. So finally we can write that B2, that is the formula for the magnetic field at the equatorial point, will be mu naught upon 4 pi m upon d2 cube, that has to be equal to 0.55 multiplied by 10 to the power minus 4. So now we can solve it. Mu naught is 4 pi multiplied by 10 to the power minus 7 divided by 4 pi. M is the magnetic moment for the second magnet and it has been given to us as 4 ampere meter square. So we can write 4 divided by d2 cube. That's what we need to find. And finally, we can solve it. This 4 pi gets cancelled out with this 4 pi. And d2 cube will be equal to 4 multiplied by 10 to the power minus 7 divided by 0.55 multiplied by 10 to the power minus 4. So when we solve it out, 4 divided by 0.55 is 7.27. And this 10 to the power minus 4 will go in the numerator. It will make it 10 to the power minus 3. So now d2, it is the cube root of 7.27 multiplied by 10 to the power minus 3, whole power 1 by 3. The cube root of 7.27 is 1.924 and the cube root of 10 to the power minus 3 is 10 to the power minus 1. And finally, we can convert it into centimeters. This is in meters. So multiply this by 100, we'll be getting d2 will be equal to 19.24 centimeter. So, in order to make the magnetic field at P to be 0, we need to place the second magnet at a distance 19.24 centimeter from the point P. Let's solve part B as well. Describe the consequence of reversing the polarities of magnet 2 on point P and the distance d2 from magnet 2. So if we replace the magnet in such a way that this point is S and this becomes N. So we have changed the polarities now. So now the magnetic field B2 created by magnet 2, it will always be in the upward direction. So at equatorial point, it will be from north to south, opposite to that of the magnetic moment. So all the three fields B1, BH and B2 are in same direction. And when it happens, there will be no such distance d2 at which magnet 2 can be placed in order to make the field 0 at P. So we cannot be finding any distance d2 when the polarities are reversed, because all the fields by magnet 1, magnet 2 and the horizontal component of Earth's magnetic field, they all will be acting in the same direction. So that's why we cannot be changing the polarity to make the field 0 at point P. Thank you. Keep learning, keep practicing, keep excelling.